All right, we're going to start section 10.3 right now. Again, most of this is review for all of you. There's one element that I do not believe you've seen before, which I'll highlight. So we'll just quickly start with this warm up, and it says, how can you use the slope formula right here to create the point slope form of the equation, which is right here, right? Well, if you look at the original equation here, you can easily put this in the point slope form if you multiply by the denominator x sub 2 minus x sub 1 on both sides of the equation. Right? So the point of that was to let this denominator simplify here, and then you're left with this equation just written on the other side. X sub 2 minus x sub 1 times m equals, and then y sub 2 minus y sub 1 here, right? Now, the pieces here, this x sub 2 value here and this y sub 2 value here, we would treat like the x and the y from the original point slope form. But that's the slope formula and the point slope form of the line are the same exact relationship, equation, formula. They're just variations of each other, equivalent. All right, next example here. So we're looking at finding equations of lines, right? So let's just talk about the forms that you have to be familiar with for this section. You're familiar with all of them except the last one here. So we've been talking about the standard form of the equation right now, ax plus by equals c. Just a couple things, it always must be in this order. X term plus or minus the y term equals the constant term c there. The x term, the coefficient of the x term, the a, must always be positive in standard form. And then a, b, and c must be integer values. Okay, so a must be positive, a, b, and c must be integers. So that means no decimals and no fractions. Clear your decimals, clear your fractions if that's the case. Slope-intercept form we've discussed in the previous lesson, right? M is the slope, B is the B is the y coordinate of the y-intercept. Remember, if we're identifying the y-intercept, we always want to identify it as a coordinate point, 0, comma b. And we've also been talking about the slope here, right? So this new notation, delta y over delta x, we introduced the other day. That's the slope of the line. Point slope form, this is the first time we're officially discussing it in class. But the point slope form is nice because when you look at the equation in point slope form, you can see a point on the line itself, and you can see the slope right away. The point would be x sub 1, y sub 1, right? And it's any point on the line. It could be the y-intercept, it could be the x-intercept, it could be some random point. It's just any point on the line, and the slope is the slope itself again. So that means if you have multiple points on the same line, we could have a variety of different equivalent equations in the point slope form. Intercept form is different. Okay, so this is a form that you probably haven't really seen yet, and we're going to get into it right now. So the intercept form of the equation is x divided by a plus y divided by b equals 1. So it must equal 1. And you really should have an addition symbol right here, which means that the denominator here of y, the b, or the denominator here of a, could be a negative value, and in fact, it could be a fraction. A and b do not need to be integers here if the x-intercept and the y-intercept are not integer values, right? So a is the x-intercept, we're just identifying as a comma 0. B is the y-intercept, we're identifying as 0 comma b. It's pretty easy to work with, but you have to practice it because this is definitely something that will be on the assessment, and you want to have sufficient practice with it. Okay, find the slope, x-intercepts and y-intercepts of the line. There's 4 lines here. You're finding x and y-intercepts, so there's lots of different forms you could put these into. It's really up to you. Occasionally, if the equations are listed here in standard form, I like to just find the x and y-intercepts right away, and then put it into slope-intercept form to find the slope. However, there's a variety of ways to do this, so let's just check So the first line, 2x minus 3y equals 9. I manipulated it to slope-intercept form. Slope is right there, it's 2/3. But for the x and y intercepts, I'm going back to the original version of the standard form right over here. And I'm going to substitute 0 into y to find my x-intercept. I'm going to substitute 0 into x to find my y-intercept. And I end up with 9/2 as my x-intercept and 9/2 comma 0 for my x-intercept and 0, -3 for my y-intercept there. Numbers 2, 3, and 4 can be calculated in a similar manner here. Let's see if I can get all this up for us. Right, I don't know why I can't lower my screen. Get rid of that. Maybe now I can. So same process. Slope-intercept form is probably the best way to identify the slope for these. So number 2, the slope is -1/2 once it's in slope-intercept form. And then again, you can go back to the original part of the equation to find your x-intercept. It's going to be 1, 0, and your y-intercept is going to be 0, 1/2 here. I know that's why it's so hard for me to display that for you right now. Sorry. That's 0, 1/2. Same thing with number 3, right? Put it into slope-intercept form. The slope is 4, right? And then your x-intercept, same way, plug 0 into y, solve for x, you get -1/2. For the y-intercept, you're going to plug 0 into x, solve for y, you get 0, 2 as your y-intercept there. Number 4 is unique, right? Number 4, x equals -3 is a vertical line. Vertical lines have no slope, which means they have an undefined slope, and that's how you should express it, undefined. The x-intercept, it's going to cross exactly where x equals -3 is, so the x-intercept is -3, 0, and in this particular case, there is no y-intercept whatsoever,